So GUI toolkits for Python and beyond. I said that and beyond because this is not really only about toolkits for Python. Some of these things that we are going to discuss are putting the concept that we have been discussing into practice. So they are illustrative of how to use architectural patterns, how to use event-driven programming, and that's information that you could apply to other languages. Besides, but I will not anticipate things. So, what about the contents? First, there will be a very big overview of the landscape of GUIs toolkits for Python. There are lots of them. Then I will talk about something that very few people knows about, and it's an incredibly powerful tool, which is the command line interface to GUI converters. You will see what it is and how it works and what you can do with it. Then I will discuss in detail a few more of the toolkits, comparing some of the features of each of them. All of them have the same basic stuff, so they all of them have buttons, drop-down lists, text areas, labels. All of that is the same in all of them. So I'm not going to enter into that because there's no difference. They might have different name, but there's not that much difference. But there are a few differences between some of them. Well, the main GUIs available for Python that it's very worth to discuss because it's what will make you choose one or the other when you start working on this. And then there will be a live demo of well, actually there will be several live demos of software. I have added the links to the repository that contains the demos that I will be running. You have instructions for installing if you want to try them on your own. We will discuss some parts of the code, but yeah, it's for you to look into in your free time. It's not really to go through it yourself during the workshop, but I will use all that information during the workshop to show how things work. So the landscape of GUIs for Python, the first thing that I have to mention is that Python toolkits for Python are not Python. They are wrappers to libraries written in other lower level languages. Typically, this will be C or C++. And since they are wrappers to other libraries, these libraries often provide bindings to other languages. So there's a typical example is Qt. Qt is a C++ library. You have bindings for it in Python, two different types of bindings, but you have Python for it in Perl, in Ruby, C++, obviously. So you can use it very much the same way in many programming languages. So many of the things that if you know how to use it or the features it has in one language, it's very easy for you to export those things to the language of your choice. And for example, in my case, I very often been reading documentation about how to use a toolkit in one particular language when I was planning to use it in Python, simply because the documentation in that language was better than the documentation for that toolkit in Python. But many of the information that I was the information I wanted to get were very similar in both cases. So this is to encourage you to stick around and to pay attention, even if you don't care about Python at all, because some of these things will be reusable for your case when you use a different language. So this is an example of all the things that I have found that are GUI toolkits for Python. There are quite a few developed over the years for different purposes related to different underlying libraries, graphics libraries. Some of them are only for Windows, some of them are only for MacOS, some of them are only for Linux. Yeah, some of them are specifically designed for games, Pygame. It's not surprising that has that name. But yeah, there are many of them. Most of them are dead by now, to be honest. They are discontinued for one or other reason, or have been absorbed or change name and continue as a different toolkit. I'm going to talk today about those that are highlighted in orange. So Jupyter widgets, Kibi, PyQt, PySide2, tkinter, WX Python, and 3 converters, GUI, Quick, and Clear. Sorry, Clear to GUI. We are going to start with these last 3. Wait, let's ask, do any of you have heard or are familiar with any of this? I seem to remember that some of you were already coding a GUI in Python. So are you familiar with any of this?
I think I've used PyQt and a long time ago, a little bit. But
okay, maybe it says tkinter. Yeah, that's also a very common one.
Yeah, I think so as well. Yeah, I remember learning on one of these like basic ones, but I don't remember which one might have been.
Well, PyQt or tkinter are both the traditional ones. Well, GTK, this one, PyGTK, it's also a very traditional toolkit that now it doesn't exist anymore, and it has become PyGObject. I think it has evolved in that one. Janice has used Jupyter widgets. Dominic, PyQt. Okay. Perfect. So it's because it has been, it's the Qt toolkit of choice for some project, MatIT project. So yeah, I'm glad that you have heard about some of these. We will give some more detail on them, but I'm going to talk first about the converters. Have any of you heard about any of those 3 converters, GUI, Quick, and Clear to GUI? Do they ring a bell at all? I bet not, because myself, I haven't heard of them until very recently. Okay, so let's talk about them. GUI converters are a very simple, very straightforward way of converting a command line application into a simple GUI. So you have a command line application written in Python that you have been using, and you want a GUI with a minimum effort. Well, that can be done very easily with one of these converters. The result, the GUI that you get, is not fancy. So it is literally an interface, a visual interface to the command line interface. But it is so easy to create this interface that it is worth to implement it just because it is easy. And more importantly, if you are thinking on working on a GUI for your application and you don't know whether it is worth investing time on it, it might be useful as an intermediate step for a full feature GUI. Because coding a command line interface is very easy, very cheap, doesn't take time, so you don't need to learn about any event-driven programming, any multi-threading. And adding this GUI once you have the command line interface is very, very easy, as you will see. This is where the first demo comes into play. So let's see if this doesn't break. Can you see this code? There's a screen on the left with some code and a terminal on the right. If anyone can raise the hand saying yes, or put something in the chat to make sure that yes, fine. So the one on the left is just a very simple script that asks a Python script that asks for some integers and process the arguments. And depending on when there is a flag called sum or not, it will calculate either the max of those integers or sum together the integers. When we use this application in terminal, we get something like this: Python main.py. If I don't put any argument, it says, well, there's an error. We need some input. We need some arguments. So let's add some arguments. 3, 4, 54. The result 54, because the default behavior is to provide the maximum of the arguments that I am providing. Now let's use instead the flag sum. And in that case, what it does is accumulate all the values, and the result is 61. And of course, as with many many command line applications, we can add the -h flag, and we get some well, information on how to use the tool. So very simple, but a very typical case of a command line interface application. Good. Now let's say that we want to transform this into a GUI, into a graphical user interface. Well, it might take some time, but we can use one of those command line to interface converters. I'm going to use one that it's the one that I know. It's not necessarily the best, not the one that I recommend. It's just the one that I know more about because it's the one I've used before. It's GUI. GUI import GUI, and then we use something that in Python is called a decorator. Save the file, and that's it. Those are all the changes that I have done to the code. You have seen it. And I haven't done anything else. Just import this tool and decorate my main function, the one that contains all the arguments with this GUI decorator. Now let's run this again. Let's see what happens. We are going to run it without any arguments. When we did this before, we were getting just information that we needed some arguments. If we run it now, we get something that has gone to my other screen. This is what we get. We have a very simple, very basic graphical user interface asking for the same things. It's asking for a series of integer arguments. Let's add them here. And it gives me the option to select that sum or not. If we run this, we get 6. In this case, is the maximum. I might want to sum the integers instead. We get 18, which is the output of adding together those integers. And that's it. There's some errors, but don't worry about this. This is for a different thing. This has nothing to do with the toolkit. So we have converted with 2 extra lines of code a command line application into a graphical user interface. Granted, it's not beautiful, it's not very complex, but this is a toy example, so it's not doing anything that useful. But with 0 effort, it's worthwhile to consider when you have a command line application and you want to see how to use it from a graphical perspective. So this is extremely convenient because you go from here, from the left, to something on the right that, well, it's visual. You have all the input parameters that you have some description of the application on the top. You have some the required arguments that you need to provide, and it says required arguments. You know that you need to provide them and describes what they are. You have the optional arguments, everything at once at first sight, without having to run multiple things, and more accessible to potential users. As I said, it's not fancy, it's not that sophisticated, but it is so easy to implement that why not doing it? Well, this slide actually shouldn't be here because I've done but it is useful. So you can see side by side the two examples. The only difference that we have is these 2 lines of code. Everything else is exactly the same, and we have gained with 0 effort a graphical user interface. So there are several GUI converters that I'm aware of. I've used GUI, is the one that I'm familiar with, not necessarily the best. Click to GUI seems to be more advanced. I have taken this information from the Click to GUI webpage. Click to GUI seems to be able to deal with other methods for providing arguments to Python programs, which gives more flexibility. It also can deal GUI. GUI is created using the WX Python WX, which is toolkit, whereas Click to GUI can use tkinter or Qt or even provide some sort of web interface. I haven't tried that, so I don't know how that will work. And it has some extra features, but anyway, all of them operate in a very, well, at least GUI and Click to GUI operate in a very similar way. You import the library and you decorate the function that will process the arguments. This process is not perfect, so they often offer you the option to a more fine-grained control of what the widgets containing this information should look like, or where should they be located. So what's the information that needs to be provided. So what I have shown is the most simple example possible, but they offer a lot of flexibility to customize this GUI and to provide more information. But the important bit here is that they are very, very easy to use. If you have a command line interface, or if you can create with little effort a command line interface for your program, adding CLI to GUI converter will make it to your application to a graphical user interface with very, very little effort. And that might be all that you need. You don't need to worry about implementing a more complex application. If you do need a more complex application, because you need to include plots, because you need to interact in more complex ways with the application, because you don't like the GUI that these converters give you, that's absolutely fine. That's where we have to include a proper graphical user interface for a toolkit for Python in this case. We are not going to go into the detail of these buttons, different widgets, labels, things like that. All of them operate in a very similar way. What I'm going to describe or comment is on a set or a collection of several aspects that I think that they are defining when you have to choose between one or another. So what's the underlying library that is going to that particular toolkit is using? The license, very important. Documentation for that particular toolkit, the platform that toolkit will let you run your application. Comments on multi-threading and multiprocessing when using that toolkit, whether they support assistive technologies like screen readers and things like that, related with accessibility of the software. In the end, that's one of the advantages of having a GUI, to be able to make your application more accessible. So assistive technologies go into that direction. Internationalization, so providing your GUI in different languages, that again, accessibility of the software. Customization of the look and feel, changing the fonts, colors, the size of the fonts. The learning curve to start using that toolkit at all. And also the maturity of the toolkit. Some of them are very young, some of them are very old, and there are advantages and drawbacks in both cases. So this is the table. You will not find this table many places. So I hope that you appreciate the information that it contains. It summarizes what I think are the 6 most important or relevant GUI toolkits out there for Python. As I mentioned, they are not native Python stuff. They are wrappers were created on top of existing C++ libraries, except for the case of Jupyter widgets, where the underlying library is actually the full web stack, CSS, HTML, and JavaScript. It's a bit weird, but that's the case. For the case of WX Python, it uses WX widgets that in turn uses the native graphical libraries of that particular operating system when it is run. So it will use whatever Windows uses, which I don't know what it is. It will use Cocoa for macOS. It will use, well, for Linux, it will depend on the sort of desktop that you are running in Linux. So it will adapt to what the application is being run into. And that makes WX widgets the only one that actually will provide a native experience to the user. So applications created with WX Python will look very much integrated into the operating system, regardless whether you run it in Python, in Linux, in Mac, or in Windows. License is very important for software. That's something you should always be aware of. All of them are rather permissive, so you can do whatever you want with Jupyter widgets. Kibi, tkinter, which is also a very big part of tkinter, that is part of the Python standard library, so it has the same license as Python. And WXPython license is also quite permissive. It's some sort of relaxed version of the lesser general public license. But PySide2 and PyQt, PySide2 and PyQt, both based on Qt. Qt is a commercial, well, somewhat commercial tool, and it imposes some restrictions on the licenses of the software that it's using it or that is derived from it. And this is the pretty much, I mean, there are other fundamental differences between PySide2 and PyQt, but the main reason, the main difference between both, and the reason that some people prefer to use one or the other, is precisely the license. While PyQt, it's released only under the GPL license, general public license, or commercial license. That means that your application has to be either GPL or you have to pay for or either your application is open source and released under the GPL license, or your application is whatever you want, but you have to pay for a license, a lot of money for the license for using the library. That's PyQt. Those are the only two options. You cannot use this library in a software that is not going to be open source unless you pay for the license. And PySide2, it's a little bit better, I think, in that sense, because it lets you use the library in a software that is not going to be open source using the lesser general public license. But as the lesser general public license imposes, there is some restriction or something that you need to take into account in order to do that. But in principle, you can have your software not being open source and using PySide2. This is very important. You are thinking on using Qt, well, any of these two flavors for your software, of Qt for your software, you need to really think whether this license scheme fits your needs, and ask whoever is in charge of legal stuff in your institution. So yeah, think about that. I'm seeing that Ben has some particular comment about Qt not being happy with the most modern Macs. That's a shame. I hope that it will be solved at some point in the near future, but it's good to know. So take that into account. Because it might be a barrier also for you in your case. But I hope that, I mean, they are pretty new, so hopefully it will be changed at some point in the near future. If they don't work with those chips, they don't, until their developers of those tools can, well, recompile things for that architecture. The funny thing about those chips is that they use the same type of architecture that mobile phone chips, ARM architecture, ARM64 architecture, and most software is not really ready, well, or compiled to work with those with that architecture. It's a bit strange. So unless they move that sort of a library to support that type of architecture, well, it will take a while to have that happening. You will have the same problem probably when running a Qt application with an Arduino, with a Raspberry Pi, which is also an ARM64 architecture. Going back to the toolkits, documentation. This again is somewhere where you will find a lot of differences. Jupyter widgets, there is documentation, there's official documentation webpage, but it's not that detailed and it's certainly improvable. Kibi, I bet you have never heard of Kibi. It's relatively new, relatively young toolkit, but it has excellent documentation. tkinter has been there forever. There's a lot of documentation, but it is very scattered. It's not concentrated in one particular place and sometimes it's contradictory or incomplete. So sometimes it's very hard to do things with Tekainter, not because it is hard. Actually, it's very easy to work with Tekainter, but simply because you cannot find the information about it. PySide2 and PyQt both have excellent documentation, probably among the best, together with Kibi. And WX Python has good documentation. It's sometimes a bit outdated. They released version 4 of WX Python relatively recently, and some of the documentation is not really updated to this new version. But in general, it is good. Maturity. Jupyter widgets is very new. Well, as new as Jupyter. Well, Jupyter newer than Jupyter. Kibi is young, but it's not. It's at least 6 years, 7 years old. That means that it has been around for some time, but doesn't have such a big community on the internet to look for help. There's not that many Stack Overflow posts about it. So that means that sometimes you will find that you are looking for to have some problem, you want to look for a solution and you cannot find it. That doesn't happen with Tekainter. It's so old that pretty much every possible answer, ask question that you have about Tekainter, it's solved somewhere. But it is borderline obsolete. The look and feel is somewhat old, and sometimes you will not find it, even though it's supposed to be part of the standard Python library. Sometimes it is missing. For example, Azure was at some point removing it from the Python image that they use in Azure pipelines, the continuous integration system, and also in GitHub Actions. And in Linux, it has always been as a separate package. So you have to install it in Ubuntu, for example. You need to install it. It's Python -tk. You have to install it specifically. If you just install Python, you don't get Tekainter. So it's on its way to disappear at some point in the future. I don't think that it's in the roadmap to remove it, but for an application that is meant to last, it might be a risky choice. PySide2 and PyQt are both mature, and also with WX widgets, they are both mature. They are both active and developed, and there's no hint that they will disappear at any point. There's a lot of information out there and help out there in the community. So yeah, it's easy to find support or answers to questions for those two. Platforms. This is another one where things differ. They all work in desktop, but Jupyter widgets runs in the browser, and therefore you can use it as a web application. There are add-ons for Jupyter where you can deploy this sort of interface on the web remotely, which can be very handy. Using, for example, Binder. I used Binder yesterday when I was showcasing Solcore, for example. And Kibi is quite unique because it runs on mobile. So you can create your application in Python with Kibi and then deploy the application in your mobile phone, which is pretty unique for Python. There's not that many toolkits that let you do that. Learning curve, everything that has a praise to Py, you have to learn. Jupyter widgets is easy, Tekainter is just a little bit more complicated, but not so much. PySide, Qt, WX widgets are steep some part of it there is not that intuitive. Kibi is a pain to learn. It's really obscure sometimes. It's very well designed, but getting into how to use it, sometimes it's really complicated, and you might have a hard time learning to use Kibi. Now we enter into linking this with what we have been discussing in the previous session. How do we use the multiprocessing and multithreading with these toolkits? Well, for multiprocessing, well, I really don't know about Jupyter widgets. I have no idea if it supports any sort of threading or multiprocessing. The point about Jupyter widgets is that it is meant to be for simple GUIs or dashboards. It's not meant to do heavy calculations of a lot of things. So I think that the use case for Jupyter widgets simply doesn't lend itself to use multithreading or multiprocessing. All the others for multiprocessing, you will need to use the multiprocessing module, which is part of the standard Python library. So there's nothing strange to be done there. You learn to use that module and you apply whatever is necessary. For threading, it's slightly different. Kibi, Tkinter, and WX widgets will use the threading module, also part of the Python standard library, with all the caveats and all the warnings on how to use it properly. So working with threads can be tricky, and there's a lot of documentation on using threads in Python to make it right. PySide and PyQt is more advanced, and it has a really good and nice interface for creating threads and dealing with threads and communicating between threads and between the main thread and the other thread. So that's really a plus for PySide 2 and PyQt, and really something that you should consider when deciding what to use, because it can make your life way easier in that sense. Customization of the look and feel. That's another area where they differ a lot. For Jupyter widgets, you need to learn CSS. In the end, it's web application, so you need to learn how to deal with that sort of coding. For Kibi, it's very complex to change the look and feel. It has its look and feel, the default one. There seems to be ways of changing it, but it is so complex, I haven't really found a way of doing it, to be honest. Tkinter, it's funny, it's easy, but it's so poorly documented that in the end is hard to do. But you can customize every single aspect of Tkinter application, the look and feel, the font size, the font type, everything can be changed. And it's really simple. There's very few things that you need to change in your code, but it's not explained properly anywhere. So in the end, it's hard because of that, because of the lack of documentation. Again, for PySide and PyQt, you see that there is a big company behind, and this is pretty easy, relatively easy to do. WX widgets, it's complex, but the point is that it's not meant to be changed manually. The whole point of WX Python is to use the native theme of the operating system that you're using. So not to let you change that at will. In general, there's less freedom to change the look and feel of a desktop application than a web application, that you will also notice. Internationalization. It turns out that there's not a huge amount of information about this. Most of them can use, or all of them can use some Python, a module within the standard Python library called getx to perform this internationalization. It's a bit convoluted to my mind, the way this has to be done, but this what you will see suggested out there. PySide 2 and WX, well, PyQt and WX Python do have some built-in features to deal with this. So you don't need to use the lower level getx, but have some higher level layer dealing with these translations. But still, it uses a lot of features of getx, so sometimes it's a bit weird. Support for assistive technologies, screen readers, magnifiers, NetApp. Only the more professional ones, PySide 2, PyQt, and WX widgets support this sort of technologies. Of course, it will depend on the specific technologies, but in principle, they do have support for those. There you have the web page for the different toolkits, so you can get more information about them, and a few other comments of each of these tools. As I mentioned, Jupyter widgets is more useful for simple GUIs, dashboards, things that do not require a lot of multitasking or a lot of heavy duty calculations in the back. And it's very handy for people who is familiar with Jupyter notebooks, because it's just another notebook. There's nothing else. Kibi is a professional toolkit. They design especially for multimedia applications. So you will see in the help, in the documentation and in the help that you find out there, a lot of people using Kibi for to dealing with photos, with videos, with games, creating games with Kibi. Tkinter, yeah, you can use it for a lot of things. It's not fancy. It has the work done. It's a bit oldish. And the most interesting part or useful part is that it's part of the standard Python library. So it has no external dependencies. You install Python. Well, you have external dependencies in Linux, in Ubuntu. You need to install it on its own. But in principle, once you install Python, you have Tkinter. You don't need to worry about anything else. PySide2 and PyQt, as well as WXPython, are both professional toolkits that you can use in professional applications that you can sell if you want, and that will look professional if you do them right. So, recommendation, well, use whatever you need. If it is something internal for yourself that you want to have running and do not expect many people to use it or use it externally, well, you can go for Tkinter or even the widgets if it is something simple. If it is something that will need to deal with a lot of video or photography data, that you can try Kibi, but make your mind that you will need to invest a lot of time working on it. For everything else, use PySide2 or WX widgets. Probably the difference there will be more related on the license. Will be the defining factor there. What you want to do with the tool, whether you want to release it publicly or you want to use it internally or even sell it. Then you will need to figure out what's the best way forward. Okay, so yeah. So now we are going to have another live demo. This is part of the workshop I gave on graphical user interfaces for Python at the LSC conference in 2019. And this was done in collaboration with other members of my team, the LSC team at Imperial College, so it's not just my work. And there we created the same application using the same model, the same business logic, but with 3 different toolkits: Jupyter widgets, Tkinter, and Kibi. Here you have a screenshot of each of them using the default settings for the look and feel. You will see that they are all very different. But they perform exactly the same tasks, which is finding the contour of an object in a photograph. In this case, they are insets. So let's see if this works. So first, this I put the link to this repository in the email I sent this morning. It's open source, MIT license. You can have a look at it, download it, change it. You have installation instructions if you want to run it yourself. The main information, the important bit, there are two important bits. First, this document here. This is the cheat sheet. It's a very, well, I think that it's a very useful. I'm going to open it here. To create a preview. So it's a Markdown document that contains somewhat a comparison between the three toolkits, including information on how to install them, what dependencies they may have. This hasn't been rendered properly. I'm going to use. I should have used this to start. How the different main types of widgets are called or are used in the different toolkits. Some description are always comparing with one with the other on how to create the widgets, the layout, how to place the widgets in the correct place, how they operate. Jupyter widgets and Kibi work in a similar way, whereas Tkinter is the one that follows a completely different approach. It's the oldest one by far, so it's normal that things have evolved since then. So I believe it's a very, very useful and powerful document to, even if you don't want in the end to use these particular toolkits because you are going for WX Python, for example, they are always, it's very useful to understand different ways of creating a GUI side by side. And it has a lot of examples. So it has minimum working example for the 3 of them that just creates a simple window with a button and some text in the three toolkits. So this is one of the things that is, I think it's very useful from this repository. The other are the different examples. So you have 3 examples. One is the minimum working example with the same one that it's shown in the cheat sheet. Another one is using creating a plot of data. So it's slightly a minimum working example, but it's slightly more evolved using matplotlib for plotting things. And the other one, which is the one that I'm going to talk about, is a full GUI doing something useful. These are the 3 files that we care about, including this one. And I'm just going to run them and see what happens. So they are here in my computer. I'm going to start with tkinter, tkinter. I run this. As usual, it opens in the wrong screen, so I have to move it up here. This is the application. It has some slider to select the value of some Gaussian filter. It allows you to select some parameter, and it lets you left click to create a control node, and you need at least 3 control nodes. So I click on the plot to select an initial idea of what the contour for the butterfly should look like. This will work very badly because the underlying segmentation routine is, well, it's not that sophisticated, but that's not the point. You see here one of the things that we were mentioning. Now the application is frozen. It's just working in the background, and the user cannot do anything. These applications do not have any sort of multi-threading or any sort of progress bar. That's wrong. You shouldn't do this. You should always try to run long, heavy-duty processes in the background, indicating to the user how, as a separate process, indicating to the user what's going on. It might take a while, shouldn't take too long, but it shows one of the limitations. It has tried to do some sort of segmentations to find the edges of the butterfly. It has failed spectacularly, but well, it is what it's trying to do. And we want to repeat, we remove this and we start all over again by changing the parameters and running things. So very simple, very straightforward. Doesn't look great, but that's not the point. I'm just showing what it's trying to do. I'm going to explain. So this is GUI tkinter. This is the code, and the interesting thing or the important thing that that links with what we have done in the past is that what it is. Let's see if I can find it. I cannot find it. Oh, here, yes. Sorry. The business logic, the business for the tools for adding a node to the plot and to process the segmentation are all coming from the model. This file has no information on how to do that. That information is contained in the model file, this model file, which is here, which is not that big. But it's the one that will contain the reusable information that all the toolkits will use. I'm going to do the same thing with the Kibi, the Kibi version of the tool. This one is more convoluted the way it works. It starts running more things. As usual, it appears in the wrong screen. And this is what it looks like. So the default theme, I don't know if you can see it, the default theme of Kibi is black. So everything in the background is black, but the default font size are different. The default font type is different. The colors are different. the underlying application is essentially the same thing you can do. And this is something that I have noticed that it happens a lot with Kibi. For some reason, it's not that mature. It's a relatively young tool, and sometimes it fails. Anyway, the functionality is the same. You select the edge, and you perform the segmentation. And again, it freezes, and while it is doing some background calculation, as it. Oh, this is useful. Start application main loop. This is called main loop. It's not event loop, but it is the same thing. So this provides a lot of information on what's going on. Anyway, it's doing the same thing as before. Performing this, it has called the model, called this function in the model that it's running the actual calculation. So there we already have the separation of concerns between the front end, the GUI part. Again, a horrible segmentation. We don't care. And the business logic doing the actual calculations. What's different between this one and the one of the Inter, apart from being a different toolkit? The difference is that the layout of the widgets and the color, well, not the color, but what they are, how they are located with respect to each other, is not in the Python file for the Kibi GUI. It's not here. Here there are other things. The information on where things are in a separate file that uses a dedicated declarative language called the Kibi language, that it just says where things are located in relation with each other, and that's it. So it's a description of what things are, and that's it. This is a refinement on the architectural pattern. In Inter, we only have a separation between the GUI, the front end, and the model. In Kibi, now we have three elements. We have the model, we have the view defined by the beetle, and we have the Kibi file, the Python file in Kibi, that in principle, I would say that it is a presenter because it contains functions to communicate with the view, and it also contains functions to communicate with the model. And the application model it's here. It's in this file, so it's not in the model file, and it's not in the beetle in the Kibi language file. So in Kibi, we have the actual separation and the appropriate example of the model view presenter, I would say, architectural pattern. It also has Kibi also has a very interesting built-in support for the observer pattern. So I'm not going to go through this, but you can define variables, and those variables you can ask them to be observed. Let's see if I can see one example of that happening. I don't see what was that happening, but it is happening somewhere. I don't remember where. So it implements itself the observer pattern precisely to update different parts of the GUI or execute tasks whenever something changes in the model or in the view, and that also comes very handy. The last one is the Jupyter widgets example. For Jupyter, we need to execute first the notebook, and well, we need to execute the server, and the Jupyter notebook itself is displayed in the web browser. So I'm going to run this. I'm not sure in which browser it's going to open it. Okay, perfect. This one. So it's opening Jupyter. This is the notebook. Again, you see here that we're importing things from the model. So we are reusing the same information that we have used in the others. The logic is the same in all cases. It has some extra features, and this lower part here are most likely, or what we will consider the view. It defines what are the widgets and how they relate to each other. Whereas this part up here are more related with what we will call the presenter, the one that glues the view and the model together. We run this cell, run all, and we get the same information, the same type of display with the butterfly, with the bugs. We select again an initial contour, and once it is done, we perform segmentation, and it tries to do some segmentation. It will fail as before because the underlying model is the same. So the model is failing. It's failing in the three of them because it's the same model. If we want to improve the model to have a more accurate estimate of the contour of the butterfly, we just need to change one model instead of changing three models. So it's an example of how to get reusable code by applying a particular architectural pattern, separating the concerns from the model, the view, and the presenter, which is depending on whether we're talking about Kibi, Tkinter, or Jupyter widgets, it's in one place or another. And that's it. This is all in the repository. Feel free to go there, to clone it, to play with it, to learn. The best way of learning about programming is not to attend a course about programming, but rather to have some basic knowledge about it and read other people code, ideally some code that is properly written. But yeah, feel free to play with it, to clone this, to change things, to experiment, and yeah, to learn about how different graphical user interfaces do things in Python. So to conclude this session, this lecture, command line interface CLI to GUI converters might provide all the GUI capabilities that you need. Think about them. Think about whether that's what you actually need. Think how easy it is to use them. With zero effort or very little effort, you can get a GUI. And it might serve, as I said before, as an intermediate step to a full feature GUI later on. There are a lot of GUIs out there with different features, different capabilities, different licenses, different difficulties for learning them. You will need to experiment with a couple of them to decide which one is, apart from checking some objective aspects like license and things like that, you will need to experiment with them to see whether they fit your way of doing things, whether they fit your way of learning or thinking of code. In any case, regardless of which one you choose, try always to apply some sort of architectural pattern to use them. You have seen in the examples that I have run that it is possible to do it. At the very least, the model and the front end should be separated. And if you can separate this further between things that are just related with the GUI, with the visual aspect, and things that are more functional, please do it to create some sort to use the model view presenter pattern, which is very useful. And mind the cheat sheet. I have gone very fast through it, but I think that it's not for me to read through it, but actually for you to use it. Even if you don't use in the end Jupyter widgets, Kibi, or Tkinter for your project, it might serve you as inspiration or at least a guidance on what things you need to look for in your toolkit of choice. If one of you want to add, let's say, PySci2 to this cheat sheet, to make it more complete, that will be fantastic. The project is open source. Feel free to contribute to it to make it better for everyone. But that's pretty much it. Keep in mind the table with comparing the different toolkits. And yeah, please, do you have any question?
All right. Regarding to the comment of Ben, so if I have a Mac OS by Qt or by site, is not an option for me?
If it is one of the newest MacOS with this new chip that they have developed in Apple, it seems that it doesn't. I didn't know it, so it's first news for me. But it seems that it's not yet ready. Qt well, PySide and PyQt is not yet ready to run on those computers. I didn't know that, to be honest.
Okay.
I would say that having a company behind, it will not take too much time for those to adapt, but I'm not sure, to be honest. Any other question? Incredible. You don't have any more questions. Okay, that's fine then. So we will now have a break, the last break of the day. And then we will face the last part of the workshop, the theoretical part of the workshop, which is testing GUIs, testing and packaging, which is something that might have some difficulty in the case of GUIs, and it is very useful to have some guidance or comments on that. I would have really appreciated to have this information back when I started with this. So yeah, that will be the final part. It's shorter than the two that we have just had. So let's meet in around 15 minutes at 11 past, half past 11, let's say. And yeah, that's all for now. See you in a few minutes.